All right, good morning. So we are back from having our day of makeup work on Tuesday. So we're going to get back into graphing the quadratics. Now, there's actually three forms to graphing quadratic equations. We started out with graphing them from the intercept form, which is that factored form, since we had just finished the chapter on factoring. And today we're going to get into graphing quadratics in vertex form. So we're going to look at that a little bit. We're going to work on that for the next couple days, and then we'll go into standard form next week. So graphing quadratics in vertex form is one of those forms, like I just said. So one such form is called vertex form. And the reason why it's called vertex form is because you can easily find the vertex of the equation. Remember, that is that minimum or maximum of the parabola, and also the axis of symmetry. So the vertex form, as you can see here from the notes, is this y equals a times x minus h all squared plus k. So what do all those variables mean? Well, the a, and this is the same as it was in the intercept form, that a value is going to tell you if your parabola is going to open up or down. So as you might remember, if the a value is negative, the parabola is going to open down. So it's going to look more like that. And if your a value is positive, then the parabola opens up. So that's just a review. That is not going to matter what form you're working in. That a value is always determining whether your parabola is opening up or down. Now, as a little reminder, when it opens down, the vertex is then a maximum because it is the highest point on the graph. And when it opens up, your vertex is a minimum because it is the lowest point on your graph. So now the two other variables, so we just talked about this a here, but now we're going to get into this h, and then we'll talk about the k. So the h and the k have interesting effects on the graph. So the h is basically your x value. So your h is the x value of the vertex, and therefore it's also your axis of symmetry. So when you write the equation for your axis of symmetry, it's x equals, it's going to be whatever is in that h spot. This gives us the vertical line of symmetry for the parabola. Notice that there is a negative in the model, so it's x minus h. So if you remember when we solve with zero product property, we end up with the opposite sign. So the h we use will always be the opposite to what you see in the equation, and that's because when you solve for those intercepts or whatnot, you would have to use zero product property. Now the k value, so that was all about the h. The k value is the y value of the vertex. So basically you're going to take your h and your k, right? And that's going to be your vertex. So that's going to be that minimum or maximum of your parabola. So some other characteristics, the domain, which is your x values, is always all real numbers no matter what. You can input any number you want into that equation if you were making a table or a chart. The a value is positive, the graph opens up. So the range in that case would be that y is greater than or equal to whatever that k value is. If the a value is negative, then the graph would open down, and the range would be y is less than or equal to whatever that k value is. So let's take a look at a couple examples. First, we're just going to work on identifying the information. When you guys have your quiz on this, they'll be identifying information like this, and you'll also have to do questions where you look at the graphs and pick it out from there too. So if you take a look at number one, and I'm just going to kind of write my formula up at the top here again, just so we have it as a quick reference. A times x minus h squared plus k. So remember, the a value is that number that's in front of the parentheses. If you don't see anything there, like in this example, that means it's a positive 1. In the second example, we see a negative 3, so we know that a is negative 3. If A is positive 1, like the first example, then we know it's going to open up. And if we see the A in the second example is a negative, we know it's going to open down. The other thing is that in all of them, the domain, which is your x values, is all real numbers, but your range is going to be greater than or equal to if it's a positive A value. And then if you look at the other example here, it's going to be a less than or equal to. So those are all affected from the A. So now let's look at our H. So our H is the number that's being subtracted from the X in the formula. So in this one, it's just a 1. So that's why it's going to be just a positive 1, because it's always the opposite of what you see in the formula. When there's a minus there, you have to switch the sign. So if my H is 1, that means the first part of my vertex is also 1. My axis of symmetry is x equals 1. Just like in the second example here, this time you see how it says plus 4? Well, that means my H is negative 4. So the first half of my vertex is negative 4, and the axis of symmetry is x equals negative 4. Then my K value, which is this number here at the end, it's positive 2 in the first example and negative 5 in the second example. So my K value is 2. That's the second part of my vertex there. Over here, my K value is negative 5. So that's the second part of my vertex there. And then that just finishes up here with your range. So y is greater than or equal to, because A was positive, and everything has to be greater than 2 since that was my K value, and that's my minimum. And here it's going to be a maximum. So I'm going to write that down. Since A opened up, it had a minimum, which is why all the y values have to be greater than or equal to 2. But when it opened down, it had a maximum, which is why the range, all the y values had to be less than or equal to that K value. So let's do a couple more examples. Okay, these are already filled in, but just to kind of explain where we're getting this information from. Okay, so again, it's helpful to me to write down your A, H, and K. So my A in this example here is, you see just the negative there. So we would say A is negative 1. H is the number that's being subtracted in there. So that's actually going to just be a 3. And then K is this number at the end, and that's a negative 3. So we know this is going to open down, which means it's going to have a maximum. The vertex is your H, comma, and then your K, so that's going to be 3, comma, negative 3. Your axis of symmetry is going to be x equals whatever that H value is, which in this case is positive 3. Your domain is always all real numbers, and your range in this case is going to be y is less than or equal to, because it was a opening down type of vertex, and then whatever that K value is. So it's going to be less than or equal to that negative 3. All right, so let's take a look at example B right underneath. I'll go in order. So when I take a look at example B, my A value is positive 2/3. My H is negative 2, and my K is positive 10. So the A value was positive, which means the graph opens up. And whenever the graph opens up, that means it's going to have a minimum for a vertex. The vertex is going to be your H and your K. Since I know my H is this negative 2, I have a negative 2 there. It's also my axis of symmetry. And then my K was 10, so that's the other half of my vertex. And that means my range is going to be greater than or equal to 10. Domain's always all real numbers. All right, so let's look at C and D. So let's start out with the A value. Our A value here is negative 4. So my A value is -4, which means it's going to open down, and that means I'm going to have a maximum point, which is my vertex. It also means that the y is going to be less than or equal to whatever that k value is. So now my h is 8. So the first part of my vertex is 8. The axis of symmetry is x equals 8. My k value, what's my k value? Well, there is no k value here, so that means it's 0, and that means y is less than or equal to 0. Okay, and then the last one, this one is not in vertex form, this is in standard form, which I've kind of gone in a different order this year, so we haven't done standard form yet. So what you can tell is this is the a value here. It's the number in front, which would mean it's going to open up. So the y is going to be greater or equal to whatever your k value is. And then we haven't gone over how to do the vertex and the axis symmetry in this setup, which we'll get to next week. So I'm not going to go any further with that one. Okay, so now we're going to get into graphing them in the vertex form. Now, the vertex form and the intercept form are much easier to graph than the standard form, which is why I went in this order. A lot of times we do standard form first, but this year I tried to do a little bit differently since we're remote. So to graph them in vertex form, you're going to have to graph the vertex, and you're going to have to do at least one point on either side of the equation. So I'm going to show you how to do a little pattern to do that. There's a couple ways we can do it, but steps to graphing vertex form. So first thing you're going to do, obviously, is find the vertex, right? Which in this form, it's very simple. It's just the h, comma, and then the k. That's the ordered pair. That's going to be your vertex, and it's right in front of you in the formula. You don't even have to do any calculations or anything to get it. You just pick it out. You plot that. Then, obviously, plot your axis of symmetry, which you also know from that point. Then you're going to pick another value for x. And because your domain is all real numbers, you can really pick anything you want. So you want to pick a small, easy number, probably a positive if that's an option. And you'll plot it, and then you'll use your axis of symmetry to plot a point on the other side to make it symmetrical, and you'll draw your graph. So for example, let's say I'm doing this first problem, right? So first thing I'm going to do is identify my A, H, and K, right? So my A is 1. My h would be +4, and my k would be -3. So from that information, we know it's going to open up because my a is positive. We know the vertex is going to be a combination of my h and my k, so it's 4, -3. And we know the axis of symmetry is going to be x equals that h value, which in this case is 4. So x equals 4. The domain is always all real numbers, and the range will be y is greater than or equal to, since our a value is positive, and then that k value, which is -3. Okay, so the first thing we need to do is plot this vertex and the axis of symmetry. So that's what we're going to do first. Now this particular graph is blank, so I'm just going to, let's see, I'm going to make my x and y axis over here to the side, like this. And we said this one was going to open up, right? Okay, so my vertex is 4, -3. So if I go over 4 and down 3, I'm right about here. And I'm going to draw my axis of symmetry through that point. Now, we know the graph's going to open up, but where are some points on either side? So you can pick any x value you want on the left or the right, and you're going to plug it into the equation and see what you get, right? So usually 0 is a pretty good number to try. So let's try putting in a 0. So if I put in a 0 here, you could do, and you can do any numbers you want really, but I'm going to try 0. Usually that's easy to plug in. So when you do 0 - 4, you get -4, and then you're going to square it and get 16, and 16 - 3 is going to be 13. So 0, 13. But that's going to be way off my graph, so I'm going to try something else. If I pick a 4, and I put a 4 in here, 4 minus 4 is 0, and that's going to make it kind of easy. So I'm going to try 4. If I put in a 4, oh wait, I already have 4, so bad idea. Okay, so let's try something else. Let's try 5. How about that? Try 5. So if I put in a 5 for x, 5 minus 4 is 1. 1 squared is 1, and 1 minus 3 is negative 2. So I'm going to go over here and plot my point, 5, negative 2, and I'm right here. So now I'm just going to plot one on the other side of the axis of symmetry that's the same distance away, and then I can make my parabola. Now you didn't have to pick 5, you could have picked something else, so we could always check it out, like what would have happened if you picked, let's say, 6, right? So if you picked 6, 6 minus 4 is 2, 2 squared is 4, and 4 minus 3 is 1. So you should have had the point 6, 1, which would have been right there, and then right there. So pretty good, pretty good. And that's it for that. All right, so let's take a look at the next one. So again, we want to find what's A, H, and K. So my A is negative 2, which tells me it's going to open down. My H is going to be negative 1. Remember, it's always the opposite sign of what you see in the formula. And then my K is going to be positive 5. So that tells me it's opening down. My vertex is negative 1, 5, and my axis of symmetry is x equals negative 1. Domain is always all real numbers, and my range is going to be y is less than or equal to, because this was a negative, and then that k value, which is 5. So we know all the y values are going to be less than 5. So when I go to set up my grid here, 5, 4, 3, 2, 1, 0. I know I don't really need to go higher than that. And I'm just going to make my xy axis like this. Okay, so if I go to plot my first point, my vertex, I have negative 1 and 5, which is going to be right here. And that's, of course, also my axis of symmetry. So now I need to find another point or two on the parabola. So I typically like to do the positives, but you could do negatives, whichever. So it doesn't matter. So one option would be, let's say you want to plug in a 0 this time. If I plug in 0 here, 0 plus 1 is 1. 1 squared is 1. 1 times negative 2 is negative 2, and negative 2 plus 5 would be 3. So that's 1.03. And maybe I'll try another one too. I'm going to do 1. So if I put in a 1, 1 plus 1 is 2. 2 squared is 4. 4 times negative 2 is negative 8. And negative 8 plus 5 is negative 3. So I'm going to go to 1, negative 3. So now both of these are on the right side of the axis of symmetry. Notice this one here at 0, 3, it's like 1 box away. So I'm going to go 1 box away in the other direction. This one over here is like 2 boxes away from the axis of symmetry. So I'll go 2 in the other direction, and then I can draw my parabola through the points. And that's basically it. So I'm going to pull up another page with some more practice problems that we can do. So let me see if I can go up to the beginning here. Okay. So I'm going to do a few more with you just to kind of get the practice in. All right. So remember, we want to figure out our A, our H, and our K. So my A for this first problem is negative 2. And that tells me, of course, that it's going to open down, and I would have a maximum vertex. My H value is the number being subtracted from the x. And remember, it's always the opposite sign of what you see, so that's going to be a positive 1. And then my K is going to be a negative 1, which would mean my vertex is going to be 1, negative 1, and my axis of symmetry is x equals 1. So now I'm going to go ahead and graph that point, 1, negative 1, and do my axis of symmetry. And now you just have to find one more point and then match it on the other side. So if I'm going to find one more point, I can do a number for x. So obviously I don't want to pick a 1 since that's already my vertex. So I want to pick either a 2 or a 0. So I'll try a 2. So 2 minus 1 is 1. 1 squared is 1. 1 times -2 is -2. -2 minus 1 is -3. Now make sure you're using PEMDAS when you are figuring that out. Now since this point is 1 box away from that axis of symmetry, I'm going to do that 1 box away on the other side. If you wanted to pick another point, like let's say I wanted to do 3. 3 minus 1 is 2. 2 squared is 4. 4 times -2 is -8. And -8 minus 1 would be -9. So I could go 3, -9. I'd be down here. And then, of course, I could match that up on the other side of the axis of symmetry. Whoa, that was really a squiggly line there, but you get the idea. All right, so let's try number 2. So our A value is -1, so it's going to open down. My H is +4, and my K is +2. So the vertex is 4, 2, and my axis of symmetry is x equals 4. So we start out by graphing the 4, 2. So over 4 and up 2. Do the axis of symmetry. And now we're going to find a point on one of the sides and then match it up to the other. Now remember, our domain is always all real numbers for these types of problems. And our range in this case is going to be y is, now since this is opening down, the y, everything has to be less than or equal to that highest point, that maximum, which is y is less than or equal to 2. So since I have my vertex here on the +4, I'm going to plug in a +5 for my x and see what happens. So 5 minus 4 is 1. 1 squared is 1. 1 times negative is -1. And -1 plus 2 would be 1. So 5, 1. And then I'm going to match that up on the other side as well. If you wanted to do 6 or 2 and see what happens there, 6 minus 4 is 2. 2 squared is 4. 4 times a negative is -4. -4 plus 2 is -2. So that would be right here. And then I'd have to match it up on the other side of the axis of symmetry. And it should look like that. All right, so I'm going to do 2 more, and then hopefully that kind of gets you going with the hang of this. And we're going to do this again on Thursday, so no worries if you're still kind of confused. Okay, so the A value here is a +1 since there's nothing in front of the parentheses, which means it's going to open up. And of course, that vertex is going to be a minimum. The H is -2 and the K is +2, making my vertex -2, 2. And my axis of symmetry, x equals -2. My domain is all real numbers. You can just write this fancy R if you want. And then the range is y is greater than or equal to, because it's a positive A value, that K, which is 2. Okay, so to graph it, we're going to start out with the -2, +2 vertex, the axis of symmetry, vertical line going through the vertex. And now we just want to find a point on either side. So what do we want to substitute in for x? Well, I'm already at -2, so maybe I want to do -1 or -3 or 0, something like that. So let's say I do, I'm a little worried that 0 may not fit, so I'm going to try -1. So if I put in a -1, -1 plus 2 is +1. +1 squared is still +1. +1 times 1 is still +1. And then plus that 2 would give me 3. So -1 and 3. Other side of the axis of symmetry would be -3 and 3. So now let's say I tried putting in the 0. If I put in a 0 here, 0 plus 2 is 2. 2 squared is 4. 4 times 1 is 4. 4 plus 2 is 6. So 0, 6. And then, of course, the other side would be negative 4, 6. And that's how you would do that parabola. All right, and then the last one I'm going to do with you for today. My a value is positive 4, so we know that's going to open up and it's going to have a minimum. My h is negative 1. Make sure you switch the sign. K is negative 4, so my vertex is negative 1, negative 4. The axis of symmetry then is x equals negative 1. So when I go to plot that point, negative 1, and notice this grid's going by 2s, so negative 1 is just halfway over, and then down 4. My axis of symmetry is going to be that vertical line going through that point. Now I know my domain is all real numbers, so my range is y is greater than or equal to my k value, which is negative 4. So now I have to find another point to graph on here. So I'm thinking that I'm going to substitute in maybe 0. So if I do 0 plus 1, that's 1. 1 squared is 1. 1 times 4 is 4. And 4 minus 4 is 0. So 0, 0 is one of the points. Now that was half a box away. So on the other side, half a box away is going to be my corresponding point. Now I think I'm going to try another point too. I'm going to try positive 2, see if that gives me anything. So if I put in a 2, 2 plus 1 is 3. 3 squared is 9. 9 times 4 is 36. Minus 2 would be 32. But that's going to be way off my graph. So I'm just going to graph through the points that I can fit there. And it's a very long, skinny graph. Okay, so hopefully that gives you a little bit of the information about what the different variables in the vertex form actually mean and how they affect the graph. We're going to work on this a little bit more again tomorrow, and Friday we'll review a little bit as well. Please check into our meetups both Wednesday and Friday at 10:30 if you have any questions, or feel free to email or send a message on the Remind to either myself or Mr. K. And have a great rest of your day.